Welcome back to Science for Sleep, where we explore the deepest questions about reality, consciousness, and the universe itself in a calm and thoughtful way that helps you relax while expanding your understanding. If you enjoy drifting into sleep while your mind travels through science and mystery, consider subscribing, liking the video, and leaving a comment about what topic you'd like to explore next. Tonight, we are going to listen to something no human has ever truly heard. Not because it is quiet, but because it is everywhere. We are going to explore a strange and beautiful question. If the universe had a sound, what would it feel like? Not just what it would sound like to your ears, but what it would feel like in your body, in your mind, and in the deepest structure of your awareness. To begin, imagine this. Imagine there is no earth, no air, no wind, no ocean, no heartbeat, no breath, only space, endless space. Would it be silent? At first, science gives a simple answer. Yes, space is silent. Sound, as we normally experience it, is a vibration traveling through a medium like air or water. Your ears detect pressure waves. Those waves move your eardrum. Your brain translates those movements into sound. But space is almost empty. There is no air to carry those vibrations. So in the ordinary sense, space cannot carry sound. And yet, this is only the beginning of the story. Because silence does not mean stillness. And emptiness does not mean nothingness. The universe is full of motion. Stars vibrate. Galaxies spin. Black holes collide. Space itself expands. Everything is moving. Everything is oscillating. And oscillation is vibration. And vibration, under the right conditions, becomes sound. But to understand what the universe would feel like if it had a sound, we must go back. Back before stars. Back before galaxies. Back to the beginning. About 13.8 billion years ago, the observable universe existed in a state so hot and dense that matter as we know it could not exist. There were no atoms. No light moving freely. Only a dense plasma of particles and energy. In that early universe, something extraordinary happened. There were waves. Not waves in water. Not waves in air. But pressure waves in the plasma itself. These waves were created by tiny fluctuations in density. Some regions were slightly denser. Some slightly less dense. Gravity pulled matter inward. Pressure pushed it outward. This created oscillations. Compression, expansion, compression, expansion. The early universe was ringing, like a bell. In fact, scientists today call these oscillations baryon acoustic oscillations. Acoustic, meaning sound. The early universe had sound. But it was not sound as we hear it. It was sound as structure. Sound as motion. Sound as geometry. If you had been there, and somehow survived, you would not hear it with ears. You would feel it. It would pass through you. Through every particle of your body. Slow. Deep. Immense. The pitch would be unimaginably low. Far below human hearing. A single wave could take hundreds of thousands of years to complete one cycle. It would not be a note. It would be a presence. And then something happened. About 380,000 years after the beginning, the universe cooled enough for atoms to form. Light could finally travel freely. The sound waves froze into structure. Their imprint remains today in the distribution of galaxies across the universe. In a sense, the universe still carries the fossil of its first sound. And we can detect it, not with ears, but with telescopes. Now imagine that sound, not as noise, but as a vibration that shaped everything. If you could translate it into human hearing, scientists have done this. They have converted cosmic radiation into audio frequencies. And what emerges is not music. It is not chaotic. It is something else. A deep, evolving tone. Like wind across eternity. But even this is only part of the answer. Because the universe did not stop vibrating. Everywhere, vibrations continue. Stars oscillate internally. Our own sun rings like an instrument. Scientists study these vibrations in a field called helioseismology. Seismology of the sun. The sun has thousands of resonant frequencies. If you could hear them, it would sound like a vast choir. Not loud, but complex, layered, alive. And then there are black holes. Black holes are not silent either. When two black holes collide, they release gravitational waves, ripples in space-time itself. These waves stretch and compress space as they pass. In 2015, scientists detected these waves for the first time using the LIGO observatory. They converted the signal into sound. What they heard was a chirp, a rising tone lasting less than a second. This was the sound of space-time ringing. Two black holes merging over 1 billion light-years away. The universe had spoken. But still, this was translation. Human interpretation. The real vibration is not heard. It is felt. Because at the deepest level, the universe may not just contain vibrations. It may be made of them. Some theories in physics, such as string theory, propose that the fundamental building blocks of reality are tiny vibrating strings. Not strings in space, but strings that are space. Each vibration corresponds to a different particle. Matter itself may be music. Reality may be resonance. And if this is true, then you are not separate from the sound of the universe. You are part of it. Your atoms vibrate. Your cells oscillate. Your brain produces electrical rhythms. Even your thoughts emerge from patterns of activity. You are a system of vibrations inside a larger system of vibrations. Now pause for a moment and imagine this not as an idea, but as a feeling. If the universe had a sound, it would not come from outside you. It would come from within and around you at the same time. It would not begin. It would not end. It would simply exist. A continuous field of motion. Now we move into deeper territory, because some scientists believe there is something else. A background signal. A faint hum. Not from stars. Not from galaxies. But from space itself. This is called the cosmic microwave background. It fills all of space. It is the afterglow of the early universe. It is everywhere, in every direction, at all times. It is not audible, but if converted into sound, it becomes a low hiss, a whisper of the beginning. You are immersed in it right now. It passes through your body constantly. You do not hear it, but it is there. And this leads to a profound realization. Silence is not empty. Silence is full. Full of motion too subtle to detect, full of structure too vast to perceive directly. And yet, through science we are learning to listen, not with ears, but with understanding. Now, as your mind begins to drift deeper, consider this question again. If the universe had a sound, it would not just be heard, it would be experienced, it would be slow, endless, not loud, but infinite, and in a sense, you are already inside it. Rest here. And so we continue drifting deeper now, beyond the familiar idea of sound as something heard, and into sound as something that exists whether or not there is anyone to listen. Because the deeper truth is this. Sound is not defined by ears. Sound is defined by vibration. And vibration exists everywhere. Even in what we call empty space. To understand how this can be, you must first let go of the idea that space is truly empty. Space appears empty to human senses. It appears dark, still, and silent. But on the smallest scales, space is anything but still. Quantum physics tells us that even in a perfect vacuum, particles appear and disappear constantly. This phenomenon is known as quantum fluctuation. Pairs of particles briefly emerge from nothing, exist for a fraction of a second, and then vanish. This is not theory alone. It has measurable effects. One example is the Casimir effect, where two metal plates placed extremely close together in a vacuum experience a tiny force pushing them together, caused by fluctuations in the quantum vacuum itself. This means that even nothingness vibrates. Even nothingness moves. If you could somehow translate these fluctuations into sensation, they would not feel like a steady tone. They would feel like a restless shimmer. A ceaseless trembling beneath reality. Not chaotic, but alive. Now imagine scaling this up. Imagine not just quantum fluctuations but spacetime itself vibrating. Because according to Einstein's theory of general relativity, spacetime is not a rigid stage on which events unfold. Spacetime is flexible. It bends, it stretches, it ripples. When massive objects accelerate, they create waves in spacetime itself. These are gravitational waves. When a gravitational wave passes through you, it does not push you sideways. It stretches and compresses you. Not enough to feel. The effect is unimaginably small. But it happens. Your body expands and contracts by less than the width of an atomic nucleus. You do not notice, but the vibration passes through you. Constantly. Space itself is never perfectly still. If you could amplify these waves to human perception, it would feel like a slow breathing. Not your breath. The universe's breath. Expansion. Contraction. Expansion. Contraction. This brings us to something even more profound. The expansion of the universe itself. Ever since the beginning, space has been expanding. Galaxies are moving away from each other, not because they are flying through space, but because space itself is stretching. This stretching has a rhythm. Not a rhythm with a beat you could tap your foot to, but a rhythm nonetheless. Cosmologists measure this expansion using something called the Hubble constant. It describes the rate at which space expands. And this expansion creates a kind of cosmic drift. If translated into sensation, it would not feel like vibration in the usual sense. It would feel like everything slowly separating, a gradual loosening, a widening, not sudden, not violent, but inevitable. You would feel yourself carried along with it, because you are made of space too. Most of your body is empty space. Atoms are mostly empty. The nucleus occupies only a tiny fraction of the atom's volume. Electrons exist as probability clouds. Matter is not solid in the way it appears. It is structured emptiness, held together by forces, balanced by vibration. Your solidity is an illusion created by electromagnetic interactions. At the deepest level, you are motion. You are pattern. You are resonance. Now imagine what that means. If the universe has a sound and you are made of the same fabric, then you are not just hearing the sound. You are part of the sound. Your existence is one note in a cosmic chord. Not separate, not isolated, integrated. This idea appears not only in physics but in neuroscience. Your brain operates through electrical oscillations. Billions of neurons communicate using rhythmic signals. These rhythms can be measured. They are called brain waves, delta waves, theta waves, alpha waves, beta waves, gamma waves, each associated with different states of consciousness. Deep sleep, dreaming, relaxation, focus, integration. Your experience of reality depends on these rhythms. Your sense of self depends on these rhythms. Even your perception of time depends on rhythmic activity in the brain. When these rhythms change, your experience changes. Time speeds up. Time slows down. The world feels sharper or softer. Flow state, which we explored before, is associated with specific neural synchronizations. Meditation alters brain rhythms. Sleep alters brain rhythms. Consciousness itself may be a form of resonance. Not a static object, but a dynamic pattern, a process. And if consciousness is vibration, and the universe is vibration, then consciousness is not separate from the universe. It is an expression of it. Now we must be careful. This does not mean the universe is literally thinking. It does not mean the universe is conscious in the human sense. But it suggests that the same principles govern both. Structure, pattern, oscillation, integration. And now we arrive at one of the strangest discoveries in modern cosmology. The universe has a measurable background frequency. Not a sound frequency, but a radiation frequency. The cosmic microwave background. This radiation has a temperature of about 2.7 degrees above absolute zero. It fills all space. It is remarkably uniform, but not perfectly uniform. There are tiny fluctuations. These fluctuations correspond to the original sound waves of the early universe. frozen into radiation, still present, still measurable. If converted into audible sound, the cosmic microwave background would be a low hiss, soft, constant, omnipresent, not coming from any direction, coming from everywhere. If you could feel it instead of hear it, it would feel like being immersed in warm water, gentle, continuous, enveloping. You would not detect its beginning. You would not detect its end. It would simply be the environment, because it is. Even now, it passes through your body, through the walls around you, through the earth itself. The afterglow of creation remains. Now let us move into more speculative territory. There are scientists who believe the universe itself may be fundamentally informational, not made of matter at its core, but made of information, patterns of information, encoded in quantum states. If this is true, vibration becomes even more fundamental, because information requires change, and change requires variation, and variation requires oscillation. Some physicists propose that spacetime itself emerges from deeper quantum processes, processes that resemble networks, networks that resemble oscillators. In this view, reality itself arises from underlying vibration, not metaphorically, literally. This brings us to a question that has fascinated both scientists and philosophers. Why does anything exist at all? Why is there vibration instead of stillness? Why is there something instead of nothing? We do not yet know. But we know this: if absolute stillness existed, nothing could change. Nothing could evolve. Nothing could be experienced. Vibration makes existence possible. Without vibration, there would be no time, no structure, no life, no awareness. The universe exists because it moves, because it oscillates, because it resonates. And so, if you ask what the universe would feel like if it had a sound, it would feel like possibility. Not a note, not a melody, but the condition that allows melodies to exist. It would feel like the foundation beneath experience. Not loud, not intrusive, but essential, always present. Now, as your thoughts slow and your awareness softens, imagine yourself not as an observer of the universe, but as part of its vibration. Not separate, not listening from outside, but resonating from within. You do not need to hear it. You already are it. And so we continue deeper still into regions where vibration becomes so slow, so vast, and so faint that it approaches the edge of existence itself. Because not all cosmic sound is energetic. Some of it is fading. Some of it is dying. To understand this, we must turn to black holes. Black holes are often imagined as silent devourers. Regions of space where gravity becomes so strong that nothing can escape. Not light, not matter, not information, at least according to early interpretations. But black holes are not entirely silent. In fact, black holes may be the slowest ringing objects in the universe. When a black hole forms, or when two black holes merge, spacetime itself vibrates like a struck bell. Physicists call this the ring-down phase. During this phase, gravitational waves ripple outward, carrying energy away. If you could feel this ringing, it would not be sharp or loud. It would be deep, heavy. Each oscillation slower than the last. A fading tone descending into stillness. And yet, even when this ringing ends, the black hole is not completely quiet. In 1974, Stephen Hawking made a discovery that shocked the scientific world. He found that black holes are not entirely black. They emit radiation, very slowly. This radiation is now called Hawking radiation. It occurs because of quantum fluctuations at the edge of the black hole, the event horizon. Over immense periods of time, this radiation causes the black hole to lose energy, to evaporate. But this evaporation is unimaginably slow. A black hole with the mass of our sun would take about 10 years to disappear. That is longer than the current age of the universe by a factor of trillions upon trillions. If you could translate this evaporation into sound, it would not resemble anything familiar. It would be a whisper stretched across eternity. each quantum of radiation like a single grain of sand falling in a desert of time, barely perceptible, yet real. Now imagine the far future of the universe. Trillions of years from now, stars will have burned out. Galaxies will grow dark. Only black holes will remain, and even they will eventually evaporate, one by one, slowly, silently, until the last black hole disappears. At that moment, the universe may enter its final state, a state physicists call heat death. In heat death, there is no structure left, no stars, no planets, no temperature differences, no usable energy. Everything reaches equilibrium, and equilibrium is stillness. No gradients, no flows, no change, no vibration in the way we understand it. If sound is vibration, then heat death may be the universe falling silent. Not suddenly, but gradually, a long decrescendo fading into absolute quiet. And yet, even this may not be the true end, because some physicists believe the universe may not remain silent forever. There are theories suggesting that quantum fluctuations could eventually create new regions of expansion, new beginnings, new vibrations. The silence may only be temporary. Pause between breaths. This brings us to something deeply human, because when people throughout history have imagined the sound of the universe, they often describe it not as noise, but as harmony. Ancient philosophers spoke of the music of the spheres. They believed the motions of planets created cosmic music. Not audible music, but mathematical harmony. Order expressed as ratio. Structure expressed as vibration. In Hindu philosophy there is the concept of Om, not simply a sound, but the primordial vibration, the sound of creation itself. In these traditions, vibration is not merely physical. It is existential, the foundation of being. Now from a scientific perspective, these ideas are metaphorical. There is no literal cosmic chant echoing through space, but the intuition behind them is striking. Modern physics confirms that vibration is fundamental. Not mystical vibration, physical vibration, measurable, real. Now we move into even stranger territory. Some scientists have proposed that reality itself may be similar to a simulation. In certain interpretations of quantum mechanics, information appears to be more fundamental than matter. Some theorists suggest that spacetime emerges from underlying informational processes. If this were true, vibration would represent changes in information. The universe would not just feel like sound. It would be computation, patterns updating, states evolving. This idea remains speculative, but it points to something profound. Whether through fields, strings, or information, modern physics repeatedly finds the same pattern. Reality is not static. Reality is dynamic. Now imagine what this means for your experience in this moment. Your heart beats. Your lungs expand and contract. Your neurons fire in rhythmic patterns. Even at rest, your body is in motion. Life itself is vibration. Not chaotic vibration. Organized vibration. Structured motion. And this motion connects you to everything else. Not through mystical force, but through shared physical law. The same principles that govern black holes govern atoms. The same equations describe stars and cells. You are not outside the universe listening to its sound. You are one expression of it. A localized pattern in a vast field. Now imagine not hearing the universe but feeling its scale. The slow rotation of galaxies. The expansion of space. The faint whisper of ancient radiation, the distant ringing of spacetime itself, all of it unfolding whether or not it is perceived, all of it forming the stage upon which your life exists. If you could feel it fully, it would not overwhelm you. It would not roar. It would cradle you, because you evolved within it. You are adapted to its rhythm. Its laws shape your existence. Its constants define your reality. Now let your mind rest on this final realization. If the universe had a sound, it would not be separate from silence. It would include silence. Because silence is not the absence of vibration. It is the presence of vibrations too vast, too subtle, or too slow to notice. The universe does not need to announce itself. It simply is. And you, in this moment, are one of the rare structures capable of reflecting on it, not hearing it with ears, but understanding it with mind, and feeling it through existence itself. As you drift now towards sleep, imagine not a sudden silence but a gentle hum. Not a literal hum, but a sense of continuity, a reminder that everything is in motion. Everything is connected through change, and nothing is truly still. You do not need to listen for it. You only need to exist within it, because you already do. And in that realization, there is something deeply peaceful. Not because the universe is quiet, but because its motion carries you with it. Always, endlessly, without effort. Rest now inside that endless vibration, and let it carry you into sleep.